When you think about sterile processing, your mind probably jumps straight to those high-tech autoclaves, the powerful detergents, maybe the ultrasonic cleaners. But what if I told you that the single most critical factor for patient safety is something we almost never talk about? It's something that touches every single instrument at every single stage of the process. And when it fails, the whole system fails. So let's pull back the curtain on the invisible science that really determines the safety of every surgery.
Right? We see all the big machines, the complex processes, the checklists, but the answer isn't any of those things. It's something much, much more fundamental. Yeah, water. It seems so ridiculously simple, doesn't it? But what's hiding inside every single drop is a whole complex chemical story. And believe me, if we don't pay attention to that story, the consequences can be absolutely devastating. Okay, so from the very first pre-rinse all the way to the final wash, water is our most essential tool. But here's the catch. It's a total double-edged sword. If the water itself is contaminated or just off, then our entire cleaning process is basically built on a faulty foundation from the get-go. First up, let's talk about something called water hardness. Now, this has nothing to do with how the water feels. It's all about what's dissolved in it. We're talking about minerals, mostly calcium and magnesium. High levels of these minerals are what make water hard, and this creates some huge problems for us in sterile processing. And this is where things get really tricky. Look at this. Those mineral deposits? They aren't just ugly spots. They actually form a microscopic shield that can protect dangerous bacteria, hiding them from the sterilization process. It's wild. At the same time, that hard water is neutralizing the detergents we rely on and slowly choking our super expensive machinery with scale. It's basically a multi-front attack on safety. Next up, we've got pH. This is all about the acid-alkaline balance, and it is a very delicate balancing act. See, if the water is too acidic, it will literally eat away at our stainless steel instruments, causing rust and corrosion. But if it swings the other way and gets too alkaline, it can strip away the delicate protective coatings on really specialized tools. So the goal is always that perfect neutral balance. It's the only way we can be sure our cleaning process is both safe and effective. And this brings us to one of the most dangerous and invisible threats of all, biofilm. Now, we're not just talking about a few bacteria floating around. I want you to think of biofilm as a city of microbes that builds its own protective, slimy shield, anchoring itself to the inside of pipes, sinks, even the components of our washers. This is exactly why biofilm is so terrifying. It's not just sitting there, it's an active contamination factory, constantly pumping bacteria into the very water we're trying to clean with. And because it's so good at resisting our standard cleaning procedures, it becomes this hidden, persistent enemy inside the system. So a problem with water doesn't just stay in the decontamination room. Oh no, it sets off a chain reaction, a ripple effect that impacts the entire surgical journey, from the sterile processing department all the way to the operating room, and ultimately to the patient. Let's just walk through this domino effect. First, bad water quality means instruments aren't actually getting clean. That's step one. Then, because there's leftover soil or biofilm, the sterilization process fails. The sterilant simply can't reach the instrument's surface. Third, the OR staff who are incredibly sharp spot the problem, a stain, a spot, some damage, and they reject the entire tray. That causes surgical delays. And finally, the absolute worst-case scenario, a contaminated instrument slips through and is used, putting a patient at direct risk for a serious infection. Okay, so knowing all these risks, how do we fight back? We can't just cross our fingers and hope the water is safe. We have to prove it. And that means we have to get ahead of the problem through rigorous, consistent testing. This right here is our essential toolkit for taking back control. We're talking about regular tests for hardness, for pH, for microbes, and for conductivity. And listen, this isn't about just taking boxes on a checklist. This is about gathering critical intelligence on our invisible enemy. Without this data, we are completely flying blind. And the reason for all this? Well, it's simple, and it's totally non-negotiable. It's about making sure we meet established standards. It's about preventing costly damage to our instruments. And most importantly, it's about protecting the patient. Every single one of these tests links directly back to upholding the integrity of the entire sterile processing loop. So let's completely reframe how we think about water in healthcare. It's not just some passive utility that comes out of a tap. It's an active medical substance just as critical to patient outcomes as any drug or any device. Mastering its chemistry is a non-negotiable part of modern patient safety. If you remember just one thing from all of this, please let it be this simple, powerful equation. Clean water equals clean surgery. It is an unbreakable link. The success of an operation truly depends on the quality of the water that came long before it. So I'll leave you with this one question to take back with you to think about in your own environment. Is your water a powerful tool for healing, or is it a hidden risk? Because the safety of every single patient depends on knowing the answer. And that answer is found in the science we've uncovered today.